Okay. Okay, we're up. Okay, cool. Look at this. I had this cool starting soon thing. Didn't even use it right. Whatever. Um, Here I am. So, what are we doing today? A friend of mine reached out to me last week and asked me if it was possible to uh, to basically figure out what was going on from a file system perspective uh, with regards to like hot files. The question was, how do we tell which? He specifically asked what blocks are being hit the most on the file system, and or on a device rather. And so, I'm not really sure if the end goal is to have blocks on the disk or pages of a file. The reason why I say that is because if the disk moves things around on you, like your file system is an abstraction on top of your disks. You don't really know what's being placed where. And you're really only thinking about a file as like a handle and then offsets in that file. You're not really accessing like portions of a disk. Not when you go through file system like that. So the whole point is to avoid that. So anyway, the question essentially that I'm going to answer is how can you, or I'm going to try to answer, is how can you use what tools can you use to figure out like what portions of your file system are hot, meaning they're read, they're accessed the most. And so we're going to start today with just taking a look at what we can do with eBPF and seeing if we can trace the activity going on in the file system through eBPF. Now, there's a way that you can do it. So I'm just going to pull up some slides here, and hopefully the slides will help set a little bit of context here. So this all falls under kind of the eBPF umbrella. Today I took this kind of as an excuse to do an exercise with bpftrace. bpftrace is a really nice utility that essentially compiles these these kernel programs so that they can run and they can kind of understand what's going on in your within the Linux kernel while having minimal overhead. So if we take a look at like whoops. Okay. Apparently I don't have any I don't have working keyboard shortcuts anymore. So what are we going to get here? Dynamically, the description from the documentation is dynamically program the kernel for efficient networking, observability, tracing, and security. And the idea here is that we can basically stick these little programs in our kernel, and we get these signals. And so the nice thing about it is it doesn't have to go back and forth between user mode and kernel mode, so there's a performance advantage there. Because it's essentially compiled into the kernel, it's not gonna crash the kernel. It's not like we're just accessing and modifying things. It's essentially a virtual environment, and so we're fairly safe with what we can do there. It places limits as to what it can do. There's a very fairly limited set of instructions, but they're pretty powerful. And so if we use the older stuff is where we'd see BCC tools. BCC tools are really cool. I use them all the time. I've done a lot of my performance analysis using them, but unfortunately they do have some issues where depending on which version of your operating system you're using, they may not just install correctly. Like for example, Ubuntu in AWS, I've used like 4 different versions and they haven't installed correctly. And I'll just show you kind of what that looks like in a moment, and maybe I still have some of my terminal up. There's this is kind of the problem that we were talking about. Hot files or hot sectors. I'm not really sure what we need, but we're gonna go with hot files for now, just because that's the simpler one, and I'm gonna be coding this stuff. I haven't really done a lot of research looking into this. I've been sick the last few days, so I essentially have been completely away from a computer for close to a week now. So I'm not really sure what we're gonna need here, but it's okay. We'll figure it out. So this is what eBPF does, right? To answer the question about what eBPF is, we have processes, and then they're making these syscalls, and then eBPF is kind of sitting there in the middle, and it's like, hey, cool, like this is what you need, and it's great. We can find out what calls are being made and when they're being returned, and because of the way that syscalls are blocking, we just get to hang out. There's a whole bunch of BCC tools available already, right? These are ones that they're all there. But like I said, sometimes they don't work correctly. So I've been on systems recently where I've installed BCC tools and they haven't worked. I think that when I was at Netflix, I'm pretty sure that we had those installed out of the box as part of our AMI. So I'll talk a little bit if that turns into kind of an interesting topic. I can talk about that in a little bit more detail. But I have an AMI now that I'm working with, that I'm building with Packer. That's kind of a universal. My goal is to make a universal Cassandra lab image. So essentially, what we have is this one AMI that has Cassandra 3.0, 3.11, 4.0, 4.1, and the latest alpha for 5.0. And it comes with 3 different Java versions. BCC tools are installed. bpftrace is installed. That's the tool I'm talking about today. There's just a whole bunch of stuff that you're going to get for free on it. TLP Stress, the latest version of TLP Stress, is going to come with it. So that's all. I'm working on that as an open source thing. It's actually going to be part of the training program. And then for anyone interested in the training program, that's going to be Cassandra training. Starting the goal right now, my line in the sand is April 1st. I'm going to be taking signups for that soon. But the goal is to be able to provide people with production ready Cassandra class. So if you'd love to join a team that's already running or get going running Cassandra yourself, this is definitely going to be a really solid way to do it. I'm going to be bringing a lot of the lessons that I learned while running Cassandra at Netflix and Apple and the last pickle. So we're gonna be going through that in a lot of detail later. Anyway, back to this thing. So what are we doing here? Slides. We've got one of the reasons why it's really helpful to have bpftrace in your back pocket is sometimes things don't work correctly. And this happened today. I was trying to use biosnoop, and I was hitting some trouble with it. We're gonna try it again in a little bit. I've been mucking around with my system. We're gonna try it in a little bit. Biosnoop lets us it literally does exactly what we want. It tells us what's going on in the file system, and then we can parse that data out if we feel like it. So if it runs, great. We will have answered the question. But if it does not run, then we're gonna do it anyway with bpftrace. John, you're amazing. Oh, thank you, Sarma. You're the best, buddy. Appreciate you. Your consistency, man. You're amazing. So we've got this is kind of an example of what something looks like with bpftrace. So, like I said, it's a really simple language. It's very, very minimalist and allows you to kind of track what's going. It's a lot of timers, to be honest with you. The thing that on the performance side is going to be a lot of timers. There's a lot more there, but the timer stuff is what I care about today. So this is just for your information. If you need to test something out in your file system and you're not sure if you're getting a lot of if your cache is kind of messing with you and like giving you better times than you should be seeing, this is just a way to drop your page cache. So sync just makes sure that it writes everything out. Echo 3 drop caches, it purges the whole cache. So this is just a really simple way of working with stuff. Okay, so let's see. I'm just going to jump right into my terminal here. So I'm not sure how easy this is to see. Let's try making this a little smaller. Okay, there we go. So hopefully you can read that. So up here, just to give us a little, just to orient everybody. Here we have Cassandra 4.1. It looks like 4.1. So this is running off my giant image that I talked about. And then we have, you know what? Let's actually put that there. Better. And then we have this thing in the middle. This is the little script I was working on. We have a little thing down here that's just something to mess around with. TLP stress running over here. I set it to do 100 requests a second a while ago. It's just been chugging through those. I just want something happening on the file system. I actually was hoping to get something useful with flame graphs first. So if we take a look at this, so I had this flame graph, and I was actually trying to coax it into hitting the file system a bunch, but I actually got distracted trying to figure out why eBPF and bpftrace don't work correctly if you install them through packages. So that's a totally different issue that you might hit. You're probably going to need to install it from source. I grabbed a later build of bpftrace and dropped it onto my system now, just manually. That's what I'm using. Seems to be working okay. We'll see what happens here. And I grabbed that from, nope, that's my face. Here, bpftrace. So, all right, back to my terminal. So what are we doing here? Let's see. So, okay. So the idea here is that we're going to use this include. So I skipped over this kind of quickly. Let me just bounce back here why we care about this. So there's a I wrote this blog post over here, and yeah, this blog post gives us an idea, kind of a starting point. Take a look at. So recommend if you're kind of lost right now, take a look at what's going on over here. But this post, this is kind of my attempt at, to be honest, providing myself a cheat sheet, because I forget about how all this stuff works, and I use my own blogs to remind myself. This is kind of how we can get started with bpftrace. I talked about how this is available in Ubuntu 22 with the bpftrace package. Just keep in mind, you may have to install it manually, either using a build that already exists or by building it yourself. So BCC tools and bpftrace seem to have issues on AWS. Anyway, so what we have here are these trace points, and we can actually find a list of all the trace points on our system. It's not particularly difficult. Off the top of my head, it's like sys something debug trace points. We'll find it in a minute. Anyway, one of the things that I talk about here is that we have these things called these K probes, and these are kernel probes. And the cool thing is that there are these trace points. These are static. They're not going anywhere. They're pretty much set. I guess you could say that they're set in stone. And can you hear me? Am I losing my volume here? Am I losing my volume? Oh, weird. Okay, so we still have my volume. Never mind. I saw a weird volume thing. So the trace points are sitting there in the kernel. They're not going anywhere. The K probes, everything else, you kind of are sort of on your own. So as the trace points get more and more stable, the K probes will be used less and less, and then kernel developers are free to kind of like do whatever they need to them. There is no guarantee about stability around using K probes. So I'm going ahead and I'm kind of, doing whatever by using this, but you don't necessarily need to use this. Anyway, so I have this thing over here. So we're just going to go back to my terminal here, and I have this, and so I'm going to be using some of the docs and stuff as I write this. But essentially, what I'm interested in seeing is like an interval where we take a look at let's see. So we're just going to say that this is so on a 1 second interval, we're going to be printing the timer. And this right here is set up as a histogram because this is what I had before, but so this is a process and file name histogram. So let's just go with, if we're just looking for stuff that's hot on disk, we're not going to use that. And we probably just want to see what the max is. So let's just see what happens if we do that. Cool, and then we'll also clear it because we're good people. We don't want to leave this thing around. So let's see, if we run this, we watch disk, we go over here, we go sync. Okay, so this should be causing a whole bunch of stuff to go on, but see, this is just giving us the process name. That's not what we want. And this is also giving us like TCP and all sorts of non-stuff. And the reason for that is because we're using the virtual file system. So this right here, let's see. Okay, so here we have the this is using the file system to cast this this to a so we're actually casting it to a file object, and then we are taking a look at the path and the directory and then the actual name. So if we were to, let's see. So let's just say that we are going to do this. Actually, let's do read. Okay, we'll stick with reads. Oops. Come on. Okay. So what happens over here? So these are all the other files that are being hit. The question is, why is Cassandra? Now it could be because it does all the file system calls through. Look at that. Could be because it does all the file system calls through memory mapped files. Let's do by default. Let's just see if we've turned that off. My favorite thing is how long it takes to find a setting when I can't remember exactly what it is. So let's see what we got over here. Index only, no. No. Do we get rid of disk access mode? What's going on with my disk access mode? Yeah. We have this hidden. Yay! Oh, what did I do wrong here? Did I just totally biff that? So I biffed that and can't remember what the exact thing is. So we're just gonna, believe it or not, I do not remember everything associated with every internal, and I have to look stuff up all the time. So I feel like I'm taking crazy pills. Where is my disk access mode? See, now when I go into crazy mode, this is what I end up doing. Yeah. Yeah. Mm-hmm. 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 What? Oh, that's why. See if I did that wrong again. Okay. All right, we've got it now. Maybe I can actually see something useful. So the whole point of that exercise was to just change this. I have a feeling that maybe it's because I was using mmap only, and sorry, everything was mmapped, and so it was the kernel would be going to disk. So I'm not really. Let's see. Okay. So see, it's interesting because all of these have are sitting there open. Let's see. Will this work? Interesting. Okay. So the really tricky thing about these scripts is that it can be kind of hard to figure out what you're actually looking at. And since I've kind of gone like, whoops, and I've done something that's like slightly weird. Let's see. Oh, that's interesting. So this says that the this is expecting a string, but it's getting an integer. So I'm wondering if maybe I need to tap into the underlying file system call, and that might be a little bit better because if I look at like the VFS read, then I'm going to get all sorts of other stuff. And if I look at the XFS read or whatever file system this is, I didn't even actually check it. Probably the XDFS. So look at this. I didn't set anything over here. I just kind of like let it rip. So what am I going to do? Let's see. So this is my Cassandra instance because it's in which one is it? It's this one. Yeah. So I'm definitely just pushing some stuff on it right now. And it's kind of funny because I have this huge disk and I haven't done anything with it, which is kind of silly. The reason why is because the Packer script that I'm using to build these things, it shuts the instance down when it's done. So these are instance storage. So I need to set something up so that when the instance comes back up, it automatically mounts these disks, and then it will be fine. It's a little bit tricky because I'm making it work with multiple versions of Cassandra, so I have to go into all their data directories and probably create hard links. So I'll create hard links inside each of the data directories to this mount so that they all will just work. So if you just start Cassandra, it will work. So it will make upgrading easier, and I'll probably do the same thing with logs. To be honest, I'll just throw everything inside like mount Cassandra, and then everything can get mounted into a standard kind of directory structure within there. So that's kind of it's a decent best practice if you're gonna create your own AMIs. It's a good idea to just put everything on the AMI and then have anything ephemeral be living off the AMI. I mean, that's kind of the whole point. But it's nice as an alternative to using like Chef or Packer or Chef or like I'm Ansible, or if you're still using Puppet or whatever. I really prefer to just have everything baked into the AMI, and the reason why I like this is because I can have all my versions baked into the AMI. So I'll probably write some convenience start scripts that pick the right Java version and stuff like that. So I may just turn those as like services, and then that way I can start the Cassandra 3.1 service, or not 3.1 but 3.0 or 3.11 or 4.0, whatever. Anyway, so what was I doing here? I was trying to figure out what was happening with my thing here. So let's just do a bpf. Let's take a look at. So see, I was over here messing with this. So this allows us to just see whatever syscalls that we have. So let's just see if there's anything that is helpful. So we'll just see if there's an XFS trace point. No. We'll double check. I forget about the okay, so there's nothing in trace points. Oh, and I didn't even get an answer on my file system, so that was dumb. Okay, let's go right here. See, that's not what you want. ext4, okay. Okay, so if I take a look at, let's see, there should be one that's like, there should be either read or, oh, that's nice, ext4, okay, was wondering about that. Okay, so here's my read. So there's read directory block, bread, read bh, read ahead, read dir. Okay. So the question is now, I wonder what, so this is a good way of getting, instead of trying to dig through a bunch of man pages, so I like to ask myself, you know, if I know an existing command, like for example, extfs slower. Oops. See, now this is what happens sometimes. You end up with this, and even though I installed bpftrace myself, the question is, did I see, isn't that weird? Stuff just stops working. I have to reinstall BCC tools. I don't know why. Clearly something's getting moved. So anyway, the cool thing here is that this does allow you to take a look at everything that's happening in the file system. If we do the same thing, no, not OpenSnoop. It doesn't help us. We want probably BioSnoop. So let's see if this actually works. Oh, and we'll just do it for the device that we care about. We'll do this one. Let's see there, local share. Oops. See if this works. Fail. Okay. Failed to attach program, trace PID start to kprobe, block account IO start. So this is kind of a this is interesting. This is what I was talking about before, where it's like sometimes stuff just doesn't work, which is very, very frustrating. So let's just try another one. Let's try file top. Yay. Okay, so file top will actually give us the information that we want. I kind of want to see if we can let's just see if we can change the output on it. Because if it can, so we can set C to no clear, and we can also do it by process. So because this is working right out of the box, I think it's a good idea that we start with this. And the cool thing about file top is we can take a look at the source code and figure out like what it's doing. So instead of me trying to figure out everything from scratch, I'm just going to get file top to work, and then I'm going to take a look at the source code. File top will identify the places that it's hooking into, and that tells us what we would want to hook into for bpftrace if we were to write a bpftrace script. At this point, I don't know if it'll be worth the time, but we'll see. So file top. So we're going to just say don't clear the screen, and 1 second refresh, and we'll just leave it on. So what does this do? Actually, and then we'll also describe Cassandra. Okay, so there we go. So this can definitely answer the question: what files are being hit and what sections of them are hot. And actually, this is all the data that we need. So if we were to pipe this out into something else and then just use the output and write a simple parser, parse the output of the script, we can get everything that we need. Because as we see here, we're getting the number of reads, we're getting the number of writes, we're getting the and the size. Now, what this doesn't actually tell us is it doesn't break it down, like it doesn't show us the individual reads. So this is cool that it can show us the summary data, but it doesn't actually show us the specific reads. So let's take a look now. So this was the file top command. So I'm just going to jump into here. Let's see now. Oh, snap. Totally zoned out. My chair. I missed the start. Oh, well. VOD might be needed. Is the scaling off? I can't see the bottom terminal. Yeah, I need to fix this. This is, it's tough because I use a monster screen, and I miss what's going on in the bottom side of the terminal. Okay, so taking a look at file top. So this is kind of this is the easiest way, I think, to figure out what what we're doing. I'm lazy. I reverse engineer. I try and reverse engineer stuff. So these. Okay, so we got our BPF program. We're pulling in the stuff from ptrace. You fixed audio, so that's the thing. Yeah, thanks. Yeah, use my mic as it was plugged into my Scarlett, the Focusrite audio interface. Turns out when you only plug it into the left side of it, because there's one plug, it thinks it's mono. So some to mono, baby, or just do it in mono and replicate the left channel. So that's exciting. Fixing things every now and then and make a little bit of an improvement. Let's see now. Skip IO lacking a file system, so that's fun. So where does it actually register? Okay, so look, it does the same. It actually does the same thing. VSF, read, and write. Whoops. Okay, so when it does, okay, nice, thanks, real cool. Let's just call something else. Okay, so then it calls do. Oh, I see. It's because it's got both things. Do entry. So this is where we actually keep track here. So skip the IO lacking a file name. Okay, so that's okay. So we didn't have that smartness in mind before. Store counts and sizes by PID and file. Okay, PID, inode, got it. Okay, that's kind of cool. That's a little more thorough than me. Mine didn't have anything, by the way. So whatever I see here is more thorough than me. And then get current com. Okay, so it gets the actual process. Then look up or try, and it is read. So, okay, so where does it actually get the name of the file? So it has the struct of the file up here, and then it says. So this is the D. So this D entry is the same thing that I was getting before. The mode is the mode of the actual operation. So this seems like it is. Thing for scaling, probably just capture in our modern full size. Yeah. Yeah, I'll see if I can get that fixed for next time. Yeah, I wanted to do max whatever, so it should just shrink it to the right size. Let's see. So this goes to file fpath d entry. So this is now. Oops, I need this. Where did I go here? Don't need that. Don't need that anymore. Nope, not that. Not that. Not even that. I got that problem with my 4K monitor. Yeah. Yeah, I can never screen share. It's like people are, I'm like, check this out. And it's like, what are you even talking about, dude? Can't see your monitor. Tab order, yes, a little bit. Gotta clear them out every now and then. Why not on the stream? That's gonna be my next live stream. I'm just gonna go through my tabs. I had something that was actually gonna be useful here. So, oh, I remember. I was gonna bring up the, okay, so here is what we were working on before. Watch disk. So this VFS read, so this K probe, so see how it's K probe and then K ret probe? This is K return, okay? So this, when we looked at the, come on, what did I do with that? Did I really? No, I didn't. Okay, good. So this is important. So see how this says file fpath d entry, and then we see de name, that's basically this. So this structure, dname, so this is fpath, and then it goes to dentry, and then it goes to dname. So dname.len has there's something on there that I'm not looking at. Let's open it up. All right. So the actual thing that we want to take a look at is the file struct. So that's going to be like, come on. Struct file, yep. Okay. So off this, we have an fpath. There it is. So this is a, let's just, I think it's going to go into here. Okay, where's my path? Where's my path? No, not liking that. I mean, I'm pretty sure it's coming from in here, given that I wasn't really prepared to browse the kernel today. Yeah, Linux path, okay. And then we're in here. Oh no, this is filesystem.sh. I need to be in path.sh. Yeah, go with path. Path. So then you see this right here, this dentry. Jump around again. Super glamorous. This is what is actually fun. Okay, so then our this struct has a name on it somewhere. No, nothing. Is it how did I get there last time? Let's take a look at my reference post. Yep, that's where we just were. We're here. Weird. All right. So the dentry, this has a few things on here. It has this name. So it looks like that's this dname is what I had been using. and then dname must include a length. Okay, so we've got this thing right here, hash length. So what did... See, this is the trouble with doing something like this, is I'm like in this complete rabbit hole that I had no intent on going down. It's okay. This is, you go where the code takes you. What am I doing? All right, trying to figure out what is going on here with bpftrace. So we've got so we know that, basically this is where I'm going to put a little stopping point, since it's the top of the hour. And my original plan was to only do this for an hour. File top is going to be the thing that we use as our starting point. We are then going to use the information that we would figure out based on these headers, and this is, unfortunately, I think is going to be one of those things where I have to, deep rabbit hole. So yes, so now basically the key here is to grab the kernel source. Like I can't possibly do this through GitHub. I'm too reliant on my navigation through IntelliJ. So I guess I'd use CLion. I don't know. Grab this, figure out what's going on here, figure out the kernel structures that you can use, and then those allow you to use the right things in bpftrace. So once we have the right data structures, we can actually start to create the right the right tracing script. But it's a matter of getting the right thing. And so the challenge here isn't writing a trace script that works. It's actually accessing the correct structs so we can do it. And that's kind of just that's really just me kind of reading stuff and putting things together. I don't know if that's particularly interesting. So I'm just going to stop here because I think that we're at a good stopping point. If I can get this trace script figured out by the end of the day, I'm going to get it posted in my blog, along with some updates about the training program, my TLP. I just read each line of code for the kernel. Can't take that long. No big deal. So I'm going to try and do these streams every week at this time, just to make it easy for anyone who wants to watch and me. And if it picks up, then I'll do more, or I'll do some other videos. I am planning on getting a lot of content done and uploaded that's going to be freely available outside of the training program, essentially kind of like getting started with Cassandra, fundamentals that you might not necessarily you shouldn't need to pay for is kind of my take on this. There's a lot of free material out there already. There's DataStax Academy. There's lots of stuff on YouTube. I've had my blog, the TLP blog. I'm going to continue doing this stuff. The training program is really kind of focused on people who want to take that and go to the next level. Like if you want to roll into a team and diagnose problems that like you might see at like crazy high scale, larger clusters, weird schema mismatching issues like building control planes, things like that. Like the more complicated stuff that's like hard to do in a blog, but really helpful to do in a hands-on lab environment. That's going to be the training program. So we're going to be doing that stuff together. The Packer tool that I've been talking about to build these AMIs, we're going to be using that. I'm going to be doing another couple streams on that. So maybe next week I'll kind of give a tour of TLP cluster, which is probably going to get renamed because it's pretty far from the original TLP cluster vision. So yeah, if you're interested in seeing something specific, definitely let me know. Either in the comments or just hit me up directly, either in Slack or reach me at my, on LinkedIn, or just email me, info@rustyrazorblade.com. And if you're interested in consulting, same deal. So yeah, next week we're going to be doing this at the same time. And for now, the tentative plan is to talk about TLP cluster and show you kind of how that's coming along. And yeah, I'll give you a little bit more information about the training program. So, all right. Thanks very much for joining. Appreciate it. And I'll see you next week. All right. Bye.